Welcome, everybody. Thanks for joining us. I'm Jackson Felden from the Cloud Lunch and Learn team. And today we have one more great session. I have here standby with me Anupam, and he's ready to deliver a session called Serverless Microservice with DDD on GCP. And yeah, hope you can stay with us for the next 1 hour or so and to get some kind of learning on this subject. Yeah, thanks very much, Anu, for joining us today. And I believe you're ready to go. If you want to do a quick intro about yourself, and then you can take over the show.
Sure. Thanks, Jackson. Hello, everyone. Thanks for joining me today. So my name is Anu, or Anupam Forgot. I'm the founder and CTO at Nebulous Action. Nebulous Action is a consulting company here in Australia. We do help customers in their digital modernization journey and help them with the realization of AI and Gen AI based use cases. I'll talk a little bit about myself in a sec. I just want to set the scene here, give you a bit of context about the talk. So, in this talk today, which is Serverless Microservices with DDD on Google Cloud, uh, I'm looking at taking you through the synergy between domain-driven design principles and the serverless microservices architecture. So the purpose is to demonstrate how these two powerful approaches can be combined and can be deployed on Google Cloud to build applications that are highly scalable, modular, and resilient. So what are we going to cover today? So we'll look at how to set up and implement the domain-driven architecture. We'll also look at some of the best practices for combining domain-driven design practices with serverless microservices, and also look at some real-world examples on Google Cloud, just to illustrate the benefits and the challenges of this approach. You'll, by the end of session, you'll come away with a solid understanding of how to leverage the domain-driven design along with serverless services on Google Cloud Platform services like Cloud Run and GKE Autopilot. That will help you build some really powerful, business-aligned, and future-proof applications. Now, before I go any further, as I said, my name is Anu or Anupam Forgot. I'm a founder and CTO at Nebulous Action. Nebulous Action is a cloud consulting company here in Australia. I'm also a Google Cloud Champion Innovator, and I'm also a Google Cloud Authorized Trainer. So I've got 9 out of 11 Google Cloud certifications. So Google Cloud Professional Machine Learning certification is the last bit that I need to get before I take the checkbox of completing all the Google Cloud certifications. My primary area of expertise lies in architecting and implementing solutions across different technologies in cloud platform. I've worked with a number of clients to deliver tailored and cutting edge solutions primarily specific to Google Cloud. I'm also an author of Google Cloud Kubernetes Engine course that's available on Code Cloud. So feel free to connect with me on LinkedIn or using the QR code for my GKE Code Cloud course. Now, before we talk about any of the specific, I just want to set the vision here. So why are we looking at integrating, or why are we even talking about building the domain-driven design using microservices or using the serverless architecture on Google Cloud Platform? So there are three main things: scalability, modularity, and resilience. So from a scalability perspective, serverless computing on Google Cloud, it can scale automatically based on demand. So which basically means each microservice designed around a bounded context can independently scale. That ensures that the application can handle fluctuations in demand without over provisioning of the resources. Now, what I mean by resilience. So with Google Cloud serverless capabilities, we can design a highly resilient application. handling failures gracefully and automatically recovering from disruptions. So things like event-driven patterns enabled by services like PubSub that can ensure that the services can communicate reliably even when some parts of the system are down. Now, from a modularity perspective, that's where DDD principles come into play. So DDD principles help segment the application into a well-defined service that mirrors the business's structure. What I mean by that is by grouping related business logic, we make each service easier to understand, develop, and deploy independently. So now, understanding the domain-driven design is key here. So first, let's look at what exactly is domain-driven design. So as you would understand that developing the software for complex domains can be very challenging, especially in big organizations or big sectors like healthcare, finance, where there are different domains within the organization, like banking or credit cards, for example, in the financial institutions. Managing those different domains as part of the same application can be really cumbersome. So it becomes increasingly difficult to create software that accurately represents the business concepts, rules, and processes. If I talk about DDD, you would see a lot of complex pictures like this hexagon here, which is hexagonal design, or these domain services. And within domain services, you have repositories, and then you have factories, or something around the circle here on the right, where we have web service, user database, and then there are different adapters. Now, let me take a step back and try and explain DDD in a very simple layman's language. So if I look at DDD on a very high level, it is an approach to software design that emphasizes aligning the application's structure and language with the business domain it serves. So it focuses on creating a shared understanding of the business requirements and then translating those requirements into modular components. So at the very top, we have the application, the presentation layer. And then in the middle, we have the application layers. And at the bottom, we have infrastructure layer, which is bounded or integrated with the domain layer. So I'll explain I'll explain what each of these triangles or the boxes mean in a sec. But at its heart, domain-driven design is pretty much like placing the primary focus on the core domain, which is basing the complex designs on the model of the domain. If you're really interested in reading more about what domain-driven design is, there is this great book that was written by Eric Evans that describes the approach through a catalog of patterns. So this approach is particularly suited to complex domains where a lot of often messy logic needs to be organized. So I would highly recommend if you're really interested in going deep down in the domain-driven design, to have a look at this book. Now, the key principles of DDD, as I said, the main focus of domain-driven design is towards the core of the business logic. That's where domain modeling comes into the play. So in domain modeling, what we do, the core business logic is created as the domain models, and it is divided into subdomains. So I'll explain what exactly that means in the subsequent slides. But for now, domain modeling is one of the key or one of the first component of the DDD principles. Then comes bounded context. So it helps in modularizing the services, especially in large-scale applications. And the third and the last component is the strategic and tactical DDD, or strategic and tactical domain-driven design. What it is the key patterns that help define and enforce the business logic boundaries, how the different subdomains or subcomponents talk to each other within a bounded context, and how the subdomains in different bounded contexts talk to each other. Now, let's look at the domain model first. So domain modeling is pretty much a process of structuring and defining the core business logic of an application as a representation of the real world business process it aims to support. So how it works, in this particular example, we have two domains, so sales and support. Now within sales, we further have divided that domain into subdomains. So within the sales domain of an organization, we'll have subdomains like pipeline, opportunities, or the customer databases, customer list. Then we have the salesperson who is actually working on a particular pipeline or opportunity, who is managing a customer. Then we'll have the territories assigned to different customers. And then there'll be a salesperson assigned to different territories. And there can be another subdomain called product. Now, similarly, the other domain is support, where the customer subdomain is common in both the domains, but then we have ticketing system. We also have the product subdomain. So which customer raised a particular ticket for which product, and then what was the defect of that particular product, and what was the product version for which the defect was raised. So in a nutshell, in a summary, domain is or domain modeling is the process of structuring and defining the core business logic, like in this case, sales and supports. Then subdomains, for within each domain, we can have multiple subdomains representing different areas of functionality. In this example, within sales, we have pipeline, opportunity, customer, and likewise in support, we have customer, ticket, product, and defect. What are the benefits of having or doing domain modeling? So domain modeling makes the software design align with real world business requirements, making it really easy for the developers to understand and evolve the application. So it helps them to understand what is the functionality or what is the core business outcome that particular domain or that particular functionality is going to provide. It also ensures the business logic is clearly reflected in the code, leading to better maintainability and scalability. Then we have bounded context. So bounded context is a boundary within each domain, like in sales, which is consistent and fully applicable. So each bounded context defines the specific language, logic, and rules for only that particular part of the application, like in the sales, and then we have support. So these are the two bounded contexts for two different domains. So how it works, by creating the bounded context, each part of the system operates independently with its own domain model, data structures, and even rules, while interacting with other contexts through well-defined APIs or event-driven communication. So just to give you an example, in a large scale e-commerce application, there can be inventory and order processing context that would have separate models and rules for items. The inventory context might handle stock quantities, whereas the order processing manages placed orders. Though they are related, each context operates independently to reduce the complexity. So one of the main benefit of having bounded context is the modularization of the application. It enables better management of the complexity and reduces interdependencies. So one particular bounded context or domain can be scaled or updated or changed independently without impacting the other one. Now, moving on to the strategic DDD, or strategic domain-driven design. The purpose of strategic domain-driven design is to focus on a high-level design of the applications, defining the relationships and the interactions between different bounded contexts. So like in this example, we have sales and support. So the strategic domain-driven design will define how the sales bounded context or sales domain interacts with the support domain. So the context mapping happens between the bounded contexts. The strategic domain-driven design helps in establishing the context maps, which pretty much describes how the different bounded contexts interact and connect with each other. So again, the benefit of strategic domain-driven design enables a high-level architecture structure that aligns with the business objectives and reduces the complexity by breaking down the large systems into manageable domains. So you'll see the flow, how we started with a business, and then we broke the business down into different domains. In this particular example, we took sales and support. Now, within those domains as well, we created subdomains. So for sales, we had opportunity, pipeline, territory, customer, product, and salesperson. Likewise, for support, we had customer, product, ticket, defect, and product version. Now, there was a bounded context that was created for the different domains. And then using the strategic domain-driven design, we define how the two domains will be interacting with each other. Now, you must be wondering, okay, so we have two different domains, we have subdomains within the domains. Now, how are these subdomains within a bigger domain or within a bounded context are interacting with each other? And that's where the tactical domain-driven design or tactical DDD comes into the picture. So the tactical domain-driven design, it focuses on detailed design, which is sometimes also known as low-level design. It focuses on the detailed design within each bounded context, using specific patterns to organize and implement the business logic. So there are some key patterns. I won't go into the details here. So there are things like entities, value objects, or aggregates and repositories. If you're really very interested in going that deep in the to understand the concepts around domain-driven design, again, I would recommend going back to the DDD book that was written by Eric Evans. So that touches upon all the different components or the key patterns that are involved in tactical domain-driven design. But on a high level, the tactical domain-driven design helps you define the interconnections or connectivity between the subdomains within a bounded context. Now, bringing it all together, this is a picture from a blog that was written by Michael Fowler. He's a very well-known figure in DevOps or SRE industry. So that's the picture that I've taken from one of his blogs. So if I bring it all together here, so we see on the left-hand side, we have sales context, which is a domain in itself, and then there is a bounded context around that. Then we have the support context on the right-hand side, and then we have the bounded context for the support context. Then there are integration between the subdomains within each domain or each bounded context. And then using the strategic domain-driven design, we are connecting the customer and the product subdomains within each of the two domains. And we are fetching or we are using that information or that particular subdomain in both of the bounded contexts or both of the domains. Cool. Now, applying the domain-driven design in our software development. Aligning software with business goals. So by structuring the application around the core business concept, DDD helps you ensure that the software is closely aligned with the business requirements. So we are working towards an outcome, not an output. Developers and the businesses can communicate effectively using the ubiquitous language, reducing the risk of misunderstanding and misaligned expectations. Dealing with complexity. So using DDD approach helps manage complexity by breaking down large systems into smaller, more manageable bounded contexts. And each context has a clearly defined scope, which simplifies the development and testing. This is especially valuable in complex domains, as I was mentioning earlier, such as finance, healthcare, or logistics. Supporting agile development, domain-driven design works really well with the agile methodologies by enabling continuous refinement of the model and architecture. Now, as the business requirements change, the domain model can help evolve to reflect new processes and rules, making the application adaptable to change. Modular and scalable architectures. So the DDD's emphasis is on the bounded context and modular design, which makes it well suited for microservices architecture. Now, each bounded context can be implemented as an independent microservice, which allows for scalability and independent development of different parts of the application, which just makes it easier from a management perspective. Now, what are the key benefits of domain-driven design? So we have talked about what the architecture is, but why to bother even using domain-driven design? So some of the key benefits are around clarity and alignment. So domain-driven design, it ensures that the software structure reflects the business's core concepts. So as I was mentioning in the previous slide, that it helps in clearly articulating and clearly setting the expectation what the outcome is. So there is no confusion or in the understanding of what the developer thinks is required or what the business actually needs or requires. So it makes it easier for both developers and stakeholders to understand and evolve the application. Improved maintainability. So with clear boundaries and modular design, DDD makes it very easy to maintain and extend the software over time, because each part of the system is organized around a specific business function and it is independent of others. So it is very easy to maintain and improve the particular functionality of one specific bounded context or domain. Reduced complexity. By breaking down the complex system into manageable bounded contexts, DDD obviously reduces the dependencies and interconnections, which can help lower the risk of bugs and system failures, right? So whenever we talk about the monolithic applications and microservices, we always give that example of having one box comprising of all the different components that are involved in an application. And if you need to add a functionality in one of the core features, or if you need to add a feature in one of the core functionalities within the application, it pretty much impacts all the other components. Whereas in microservices, it's very easy. That's pretty much the case here as well. Enhanced collaboration. So the ubiquitous language and alignment with the business goals fosters a strong collaboration between technical and business teams, which leads to better design and fewer misunderstandings. So as I was mentioning in my one of the previous slides, the developers and the businesses, they work towards an outcome, not an output. So what's the business value? What's the outcome that adds the value to the business by designing a particular domain or the application? Right. So moving on to microservices. So before we even talk about microservices, let me take a step back. And when we had the good olden days where the application stack was sitting in a single box and all the components were so tightly integrated in a single piece of code, that's where the complexity was around monolithic applications. All the components are under one blanket. Everyone was sitting on one server. Now, with the evolution of microservices, what has happened is there's an application front end, and then the back end functionality of that particular application have been broken down into different microservices. So what are microservices? Microservices architecture is basically an approach to structure application as a collection of loosely coupled and independently deployable services. So each microservice typically handles a specific business function and communicates with other microservices via lightweight APIs. Now, why do we really need microservices? So as I touched on, the microservices prompt flexibility, as each microservice can be deployed or scaled independently. They allow teams to work on different parts of an application simultaneously. And that's where the beauty of serverless also comes into the play. So serverless is a cloud computing model where the cloud provider manages the infrastructure, allowing the developers just to focus on the code. So the serverless platforms automatically scale based on the demand, of the workload that's running on those services. And you only pay for the resources that you actually use. The microservices or the serverless architecture on the cloud platforms running for microservices, it scales up and scales down based on the load, and you only pay for the resources that you consume. So as and when it scales down, you don't pay for the resources that were previously used. And from a Google Cloud perspective, it offers serverless options like Google Cloud Run for containerized applications and GKE Autopilot for managed Kubernetes workloads. Now, you must be asking if you haven't really worked on serverless that much. Why serverless? Why not just create a bunch of VMs or just run our workload on the pods by creating the Kubernetes clusters? So the serverless architecture allows you to do rapid development and deployment without worrying about the infrastructure management, right? So you don't really have to worry about the number of servers or the number of nodes that you need to run your application workload. It is being taken care of by the cloud platform automatically. It's ideal for applications that need scalability and elasticity, as resources are allocated dynamically based on demand. So one of the main benefit is obviously the scalability, but also the cost effectiveness.
Okay, I found this on the web for what are the main benefits. Is that celebrity, but also the cost.
Sorry about that. My Google just went off. So now together, bringing the synergies or bringing the domain-driven design, serverless architecture, and microservices together, it provides and it enables the developers to build some highly scalable and cost-effective applications that are pretty much aligned with the business needs. So if I bring all the three concepts together, so when we talk about the cloud native development in the modern application architecture these days, it provides a framework for organizing microservices around business domains, making the system modular and maintainable. So microservices enable flexibility and resilience, while serverless infrastructure ensures that the application can handle varying level of traffic efficiently and economically. So this combination of domain-driven design with serverless, microservices running on serverless services on Google Cloud Platform is so relevant in today's modern architecture, when the businesses seek the architecture that can quickly adapt to changes and handle scale seamlessly, or they are looking faster time to market. Now, how if I talk about the microservices from a Google Cloud Lens perspective, how would I design the microservices running in a domain-driven design architecture on Google Cloud Platform? So we'll set up the domain-aligned microservices first. So what we'll do, the goal of domain-aligned microservices is to structure each microservices around a specific business domain. So as we looked at on a very high level in a DDD-based approach, each microservice should represent a bounded context, a self-contained module within the broader application that it adheres to specific business rules and logic. So the number one challenge would be to identify the key business domains. Start by understanding and identifying the main business domains within the application. For example, in e-commerce app, the domains could be order processing, inventory management, and customer service. So these domains form the basis of your microservices, with each service responsible for implementing the logic and the process of its particular domain. Then the second step would be to define clear boundaries of each microservice. So use DDD principles to define the boundaries for each domain, ensuring that each microservice is independent and self-contained. So when we look at these two core concepts of identifying and defining the microservices, then we can tag them with the appropriate services on Google Cloud Platform. So for example, for less complex bounded context, use something like Cloud Run services. So something like this one that I've used here. And each service encapsulates the logic and data related to that context. However, if you need more complex and you have multiple containers running for a particular microservice, you would probably choose something like the Kubernetes engine that's here. So as I was touching on my previous slide, the core concepts or the process that involves defining the microservices and aligning them well with the relevant service on Google Cloud Platform. The very first step that you take is by identifying the key business domains. Then you isolate the data per domain. What I mean by isolating data per domain, so in DDD, each bounded context should have its own data storage. So this just helps in reducing coupling between the services and prevents issues with the data consistency and synchronization. So consider using something like GCP data services around Cloud Firestore or Cloud SQL for structured data, and use something like cloud storage for your unstructured data needs. So choosing the service that best suits the needs of that particular microservice. Then the last bit here is to define the APIs for cross-service communication. So each domain-aligned microservice should expose its functionality through a well-defined APIs. It's ideally done using either RESTful APIs or gRPC, depending on the communication needs. Then we can also have the event-driven communication, which is often recommended for asynchronous tasks or to decouple services further. So this can be achieved by something like PubSub on Google Cloud. So if you have a requirement of asynchronous messaging, then make use of PubSub service on Google Cloud Platform. Or if you're looking for something synchronous, so you'll probably make use of gRPC. Right. So for as I briefly touched upon some of these things in my previous slides, so for less complex bounded contexts, use separate Cloud Run services. For more complex bounded contexts that might involve multiple interacting services or require fine-tuning grain control, use separate Kubernetes namespaces within GKE Autopilot. Consider using GCP data services like Firestore or Cloud SQL for structured data. And then for unstructured data, make use of the cloud storage. And lastly, for any asynchronous messaging type of requirements, you can make use of Cloud PubSub. And for synchronous communication, make use of gRPC. Now, one of the real-world use cases in architecture, I'm just taking e-commerce example here. So just think of this e-commerce business here. Now, we have the bounded context here, which is catalog. Then we have ordering. We have another one is shipping, then the user accounts and the recommendations. So now if I look at the product catalog, so product catalog is a stateless service managing product information, right? So I'll probably use something like Cloud Run for this particular bounded context. Now, if we talk about ordering, it handles order creation, maybe even payment processing, or inventory updates, etc. So as you see, there are multiple subdomains or multiple microservices within this bounded context, which seems a little bit complex. And it is also managing the order state. So I would probably use something like Kubernetes engine, GKE Autopilot for this particular use case. Now, again, coming to shipping. Shipping, again, to me, sounds like a stateless service for shipping labels, shipping label generations and tracking. So what I would probably do is make use of Cloud Run for this particular service. Even for user accounts, so it just manages the user registration and authentication. So I think Cloud Run in this particular case would be sufficient enough. Now, from a recommendations bounded context perspective, if I look at the main functionality of this bounded context, so it handles the personalized recommendations potentially using machine learning, etc. It requires more resources, and it might also involve some stateful components for modeling the data and data processing. So I would probably go with something like either a Cloud Run, or if, as I was saying, if it involves something around the stateful components for doing the model training, I might also consider something around GKE Autopilot. Now, in terms of communication, so the services communicate via PubSub for asynchronous events. Example, order created, maybe payment process is processed is another function. Then synchronous communication would be handled via gRPC or HTTPS. Would probably use a bunch of different storage services in this one, like Cloud SQL for the persistent data storage for different services. Now, we were talking about some of the products, so I might probably use cloud storage to host some of the product images and some of the static assets out there. Now, we were also looking at the recommendations here, right? So to do some sort of analytics and stuff. So I'll probably also use something like BigQuery. Another thing to consider here is how we do the around observability. How do we do the logging and monitoring of these services? So making use of centralized logging and monitoring of all the services would also be really helpful in this particular case. So the key message from this example that I want to give is that this particular example demonstrates how a real-world application can be built using the domain-driven principles and the serverless components. The combination of Cloud Run, GKE Autopilot, and things like PubSub. PubSub would provide a scalable, resilient, and maintainable solution. Now, I'm not saying that there's a silver bullet to design anything and everything. We just need to look at which service would make the best case for your particular scenario, right? So you might think that in my particular scenario, I don't really need the GKE Autopilot here. I mean, it's just order. I can run the functions using Cloud Run. However, I really need a Autopilot cluster, a GKE cluster for recommendations, where I will fetch the data from different sources. I'll host it somewhere in a data lake or something, and I'll process the data. Cool. Now, as they say, so there are always two sides of a coin, right? So we have talked a lot about some of the benefits and the use cases of DDD. However, it comes with its own challenges and some of the considerations that you should really bear in mind when you're thinking about using domain-driven design. Over-engineering domain-driven design. So don't overcomplicate simple domains. DDD is not the best fit solution for everything. So if your application has a relatively straightforward domain, full-blown DDD implementation might be overkill. So start with a simpler approach and only introduce DDD concepts where they add value. Avoid any unnecessary abstractions. Managing eventual consistency. So in a distributed microservices architecture, achieving strong consistency can be challenging and expensive. Be prepared to handle eventual consistency where data updates might not be immediately reflected across all the different services, because you can imagine how there are so many different components that are involved. Now, when not to use serverless, so if you have low latency requirements, if your application really requires extremely low latency, like real-time gaming or high-frequency trading, serverless might not be the best fit due to potential cold starts and some of the network latency issues that it can present. It also, the serverless functions also typically have execution time limits. So applications that require long-lived connections, example, maybe web sockets or streaming, you might need alternative solutions, or you need to design your solution carefully if you're using the serverless architecture for that. Also for the complex state management. So while serverless platforms are evolving, managing complex stateful applications in a serverless environment can still be challenging. So consider using something like GKE Autopilot for more stateful scenarios. Now, some of the other considerations is around the learning curve. So DDD and serverless is a learning curve. It's a complex methodology. It's a complex technology. It does require a lot of thinking behind before you can come up with a very robust and highly efficient domain-driven design on serverless technology. From a testing perspective, yes, thorough testing is really crucial in a distributed microservices environment. So implement unit integration and also end-to-end tests. And as I was mentioning in one of my previous slides around monitoring observability, so use monitoring tools to gain insights into the performance and health of your service. So while DDD and serverless, they offer significant benefits, it's important to be aware of some of the challenges and make informed decisions based on your application's specific needs and constraints. Now, to conclude my presentation today, I just want to leave you with some of the key takeaways. So use DDD as a guiding principle. So what I mean by that is DDD provides a structured approach to understand and to understanding and modeling complex business domains, leading to well-defined microservices with clear responsibilities. It promotes modular design, making microservices easier to develop, test, and maintain. Now, Google Cloud's serverless powerhouse has a lot of services to offer. As we looked at Cloud Run, GKE Autopilot pops up. Again, choose the appropriate service based on your particular use case. So GKE Autopilot, for example, provides a managed Kubernetes experience for more complex and stateful applications, right? So make use of the services that are there to be offered on Google Cloud Platform based on your particular use case. And there are always benefits of the combined approach. So accelerated development, enhanced scalability, improved resilience, and also the cost optimization of using a well thought after domain-driven design on the serverless capabilities of Google Cloud Platform in a microservices architecture. Last but not least, DDD, not a one-size-fits-all. So you have to carefully look at your own business use cases, your own business architecture, your own business domains, and make a call that whether using a domain-driven design architecture makes sense in your environment or just running the application on its own would be more efficient and useful. So this outlines the combines DDD principles with serverless architecture on Google Cloud, providing actionable insights and best practices on building resilient and scalable microservices. With that, I'll conclude my presentation here.
Thank you, Anu. That was a really detailed presentation, and I'm sure people from home learn a lot from your kind of step-by-step guidance. That was great. And I want to say again, thank you very much for you. I know it's very late from the place you are now, and you took the time to come here and spend and share your knowledge for the last hour. And thanks everybody from home to watching us on this session. And I hope to see you soon again. Okay, thanks very much,
Thank
and all
you.
the best, everybody.